Here's an example of using several different IRSA tools to conduct your own Dustier Messier Marathon. A Messier Marathon is something that's very popular among the amateur astronomy community, especially here in the desert southwest of the United States. Basically, if you pick a good night in March or April, you can observe all the Messier objects in one night. But if you live in the southern hemisphere, or you live in a place where March is your rainy season, you may not be so lucky. So I want to encourage you to come inside and look up what the Messier objects look like in the infrared. If you're using this for a teaching tool, you may be interested in the Cool Cosmos website. That goes through and talks about what you see when you use the infrared in astronomy. But for the most part, you can probably think of the infrared as seeing the dust. Hence my statement about using the infrared to conduct a Dustier Messier Marathon. The first thing that you want to do is assemble a list of the Messier objects in which you're interested. But you need to get it into the right format. IRSA tools use something called IPAC table format. IPAC table format is basically plain text, but it does require a little bit of formatting tweaks. So you need to start a plain text editor. That doesn't mean Microsoft Word. That probably means something like TextEdit or WordPad. In order to get an IPAC table file, you need to start by getting something that is a list of your objects with coordinates attached. It used to be that you could just get a list of objects with a header that was close to IPAC table format and just a list of names, and then pass it to the IPAC table validator routine with apply name resolution and coordinate transformation attached. But it turns out hackers are awful, and this is why we can't have nice things. So you need to figure out a way to get coordinates attached. There's a couple different ways you can do that, though. Simbad has a way that you can put a list of identifiers into their tool, and it will give you back. You can tell it, I would like everything back in, for example, decimal J2000 coordinate. Then you get back a file that's a list of all the names and all the coordinates, and then you can manipulate that into something that's close to but not quite IPAC table file format, and then use the IPAC table validator to get it strictly into IPAC table format. But you can also use this. This is called IRSA lookup. It also will take the names and then give it back to you with coordinates in an IPAC table format. You can upload something that is close to IPAC table format. So this file that I have here, it's got an IPAC table header, meaning that the first column of the first header is a pipe, then it says name, and then the last character in the header is a pipe, and then we've got all the names. So I have that ready to go. I can upload the file here and ask Ned and then Simbad to turn those names into coordinates. It takes a little while, but then it comes back with a list of all of the objects that I gave it, the name that it resolved from my input name, where it got those coordinates, what it thinks the object is, and then the position. And then when I click on download full table, then it's going to give me this already in IPAC table file format. Then I can save this page, and it will save it for me as an IPAC table file ready to go with a list of all of the coordinates that I need. Now, keep in mind that when you go to save this, it needs to be something .tbl. If you're on a Windows machine, it may complain bitterly about this. Unfortunately, I'm not sure about a way around that. It is just a plain text file, and it needs to be a .tbl file in order for IRSA tools to understand it. Okay, so let's go to the IRSA homepage, and now let's go to Find Your Chart. Then instead of single position, let's go multiple positions, and let's go and get that file that we just saved. We're going to quickly find that all of the Messier objects are not the same size in the sky, and we may need to request different image sizes for different kinds of Messier objects. But for purposes of this example, I'm just going to go ahead and ask for 20 arc minutes, since that'll probably give us a sense of scale for most of the objects. I'm on a laptop, but it's a big laptop, so I'm going to pick large. You might want smaller, medium displays. Then we need to select what images we want. DSS and SDSS are optical images. DSS is the scanned, digitized sky survey plates from the Palomar Observatory Sky Survey, so optical data largely from the 1950s. Sloan Digital Sky Survey is a ground-based optical 5-band survey which operates in the northern hemisphere, but it doesn't do the whole sky. It does a lot of it, though. 2MASS is a ground-based near-infrared survey that does the whole sky. WISE is a space-based mid-infrared survey that does the whole sky. It has 4 bands between 3.5 and 22 microns. The Spitzer Space Telescope was a pointed observatory, so it didn't do the whole sky, but most of the Messier objects are in there, I believe. Akari was a Japanese mid and far infrared mission. The images that we have here are all far infrared, and IRSA was the first all-sky infrared survey. I'm going to recommend that you turn off searching the corresponding catalogs because it will quickly become overwhelming. Okay, search. So for each one of the Messier objects that's loading the same chunk of sky is pulled from several different surveys. This first row is all digitized sky surveys. So you can see 1951, 1951, and then here 1992, 1991, 1998. There's a follow-up survey in the 90s. So these are optical. That's near infrared. 2MASS is near infrared. WISE, again, is mid-infrared. Now Spitzer, you can see, it didn't do the whole sky. It did pointed observations, so you can see the edge of the observations there, but it has observations of M1. Here's the Akari image of it. You can see the pixels are larger than they were for Spitzer. And then IRSA, you can see the pixels are even larger because it was the first survey done in the infrared, so of course the pixels were huge. So you can start to see that there's lots of differences already between all of these different surveys. If you click on this icon, it will add at the end of each row a color image that it has assembled from the images in each row. You can change the color table for each of these black and white images. To do this, click on the image that you want to change, then go up to the color table, and you pull up the color stretch pop-up. Here you have a histogram of the values in that image, and you can change what stretch type you're using. You can change the range that you're using. And if you change to a color image, you can change each of the red, green, and blue planes separately. The reason you might want to do this is because depending on the object that you're looking at, it may be that you want to see some of the finer details near the core of the object or near the edge of the object, because some of these objects are really, really bright. So bright that they're saturated. So it may be that for some of these objects, you need to spend some time playing with the color stretch and the color table to try to see what details you can pull out of the images, because it may be that the default image color table is not what you want to use. You can also measure distances on the image. You can measure the angular distance. So you can go through, for example, and measure the relative sizes of all of the Messier objects. Let's end that distance measure. You can also prepare download. You can download all of the FITS images for just the current target or all of the targets. You can also save all of the PNG files if you want. If you wanted to include the color images that you've created, you can do that too. So this should occupy you for a little while on a cloudy night. You can go through the list and see what objects look the same across all wavelengths and which look different. What things are bright in the optical, what things are bright in the infrared. There's a lot of astrophysics to be had in how these objects look the same or look different across all of these wavelengths. And if you get bored with Finder Chart, if you go to the main IRSA page, you can go to IRSA Viewer. This gets you access to even more data. So if you find a particular object that you're interested in, we were looking just now at M8, you can go and see, is there even longer wavelength data to be had? Yes, you can go and get Herschel data from M8, and you can see what it looks like at 250, 350, and 500 microns. This is less easy to use than Finder Chart, but it gets you access to more data. And I haven't even shown you how to work with catalogs. There's lots of other videos that go through that. I encourage you to get started playing around.